Hello everyone, welcome back with me, Cristian Burnt Garcia Amos. I'm from the Information Systems program, Class B, studying at Samratulangi University, Manado. I've created an animation using Blender as part of completing one of my courses, Set Theory and Logic. Not only did I create an animation, but I also included explanations of some topics. Curious about what those topics are? Let's watch until the end. Today, we will discuss a very important topic in the world of electronics and technology: transistors and logic gates. Have you ever wondered how devices like computers, smartphones, or even smart lights operate so intelligently and efficiently? Behind all these advanced technologies lies a small yet revolutionary component called the transistor, along with a logical system known as logic gates. By understanding transistors and logic gates, we not only learn about the technical components but also explore how they serve as the foundation for major innovations that shape our lives today. So, let us begin our journey into the fascinating world of electronics. A transistor is a semiconductor device that can act as an amplifier or a switch. It controls the flow of electric current through a circuit by using a small input current or voltage to control a larger output current. Transistors are fundamental building blocks of modern electronic devices like computers, smartphones, and more. There are two main types of transistors: BJT, bipolar junction transistor, and FET, field effect transistor. The principle of operation for each is different, but the overall idea is similar. A transistor has three regions: in BJTs, emitter, base, and collector; in FETs, source, gate, and drain, that control current flow. Logic gates are basic building blocks of digital circuits. They perform logical operations based on one or more binary inputs to produce a single output. Below are the explanations of three fundamental logic gates: NOT, and OR. NOT gate, inverter. Function: the NOT gate inverts or negates its input. It takes a single input and produces the opposite output. Symbol: a triangle, representing the logic operation, with a small circle, representing negation, at the output. Truth table: input, A, 0, 1, output, Y, 1, 0. Explanation: if the input is 0, the output will be 1. If the input is 1, the output will be 0. The NOT gate is used in digital circuits to reverse or invert the state of a signal. AND gate function: the AND gate outputs 1 only when all of its inputs are 1. If any input is 0, the output will be 0. Symbol: a flat-ended shape, like a D, with multiple input lines and one output line. Truth table: for two inputs, input A, 0, 0, 1, 1 input B, 0, 1, 0, 1 input C, 0, 0, 0, 1. Explanation: the AND gate requires all inputs to be 1 for the output to be 1. If any input is 0, the output will be 0. This gate is used to represent a condition that can only be true when multiple conditions are all true. OR gate function: the OR gate outputs 1 if any one or more of its inputs is 1. It outputs 0 only when all inputs are 0. Symbol: a curved shape, like a shield, with 2 or more input lines and 1 output line. Truth table: for two inputs, input A, 0, 0, 1, 1 input B, 0, 1, 0, 1 input Y, 0, 1, 1, 1. Explanation: the OR gate produces an output of 1 if at least one of the inputs is 1. It only outputs 0 when both inputs are 0. This gate is useful when you need an output to be true if any one of multiple conditions is true. Summary of logic gates. 1. NOT gate inverts the input. Input 1 output 0 input 0 output 1. 2. AND gate outputs 1 only when all inputs are 1. Input 1, 1 output 1 otherwise output 0. 3. OR gate outputs 1 when any input is 1. Input 0, 1 or 1, 0 or 1, 1 output 1 input 0, 0 output 0. These gates are the foundation for digital circuits and computing, forming the basis of more complex operations and logic. Conclusion on the principle of a transistor. A transistor is a semiconductor device that functions to amplify or switch electrical current in a circuit. Its working principle relies on the ability to control the flow of electrical current using a small input signal, current or voltage, to control a larger current flow. There are two main types of transistors: BJT, bipolar junction transistor, and FET, field effect transistor.